Finding the equation of a line from a given graph. Now, let's suppose that we have no other information except a linear graph and want to know the equation of that line. This should not be a problem given the useful information we can collect from the graph. First, we identify two distinct points with easily identifiable coordinates. It is better to use the intercepts with the axes, but this is not always possible. Then we find the gradient m. The last step involves the substitution of one of the known points in the equation to find the constant n, as we did in the previous paragraph. Let's consider an example to clarify this point. Example: find the equation represented graphically by the line. We have the following shown on screen. Solution. First, let's identify two distinct points on the graph. The first is easy, as it represents the y-intercept p, 0, 4. Another point with clear coordinates is the point r, 4, -6, as shown in the figure. We have the following shown on screen. We take P as the first point, as it is the leftmost one. Thus, from the formula of gradient m, we have the following shown on screen. Now, we substitute the coordinates of any known point, for example P, in the line's equation. We have the following shown on screen. To calculate the value of the constant n. Thus, given that x, p equals 0 and y, p equals 4, we have the following shown on screen. Therefore, the equation of the line shown in the figure, we have the following shown on screen. That is all for lesson 14.3.4, and the end of tutorial 14.3. To continue this chapter, please watch 14.4, Introduction to Parallel, Perpendicular, and Intersecting Graphs. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.com.